Okay, so this is 18.4 part 2, and we were just on example 6. So it says a fireman leaned a 36-foot ladder against a building. So again, you're going to have to draw a picture, and you're going to need a building. There's the building. I know it's a beautiful building. And he leaned a 36-foot ladder. So here's our ladder leaning against the building that is 36 feet long. Okay, and this creates a right triangle, which is what is necessary for us to use our trigonometry on. And we always have to figure out where the triangle is. So that's our triangle right there. And if he placed the ladder 7 feet from the base of the building, so here's the base of the building, here's the base of the ladder, in between that is 7 feet. So I have to make sure we understand where to put that 7 feet from the base of the building, where it goes. What angle is formed? So we're looking at an angle. We need a theta. Remember, for angles, we use thetas, theta degrees. What angle is formed between the ladder and the ground? So the ladder's here, the ground's here. That's this angle right there between the ladder and the ground, theta degrees. Okay, so again, it's very important that you are able to set up this picture or draw a diagram of it so that you know which sides are related and where the angle is. So first thing we're going to do is label sides. This side runs right into the angle, and it's one of the legs that form the 90-degree angle, so it's going to be adjacent. This side is right across from the hypotenuse, so it's hypotenuse. Okay, so you have an A and an H. A and an H is cosine. Adjacent divided by hypotenuse. So we have theta degrees is equal to cosine inverse, and the sides are adjacent is 7 and hypotenuse is 36. So we'll plug that into the calculator, second cosine, and then 7 divide 36, and that's approximately 78.79 degrees, which is approximately 79 degrees. All right, that's the angle that they need to place the ladder at in order to get, I don't know, that's just the angle. They want it 7 feet away from the building. Maybe by fire code, they have to have it 7 feet away from the building. Okay, so the next thing I was going to do is I was just going to set up a few or do a few of the problems on the homework. I'm just going to go ahead and move down to 7. We'll do one like that, and then I'll help you set up 8 and 9 maybe, and then see how you do on number 10. All right, so on number 7, this is our degree, our angle, x degrees there. This side, I haven't done this so much, but usually it's helpful to find your hypotenuse first, just because you know the hypotenuse is across from the 90-degree angle, and it's not one of the O's or A's. So 36 happens to be the hypotenuse, so there it is. All right, and then this is the other side. It's 31, and it runs right into the angle, so it's adjacent. So we have adjacent and hypotenuse. That's cosine, right? So cosine ka, so ka toa. Cosine is your adjacent divided by hypotenuse. So what we'll do is we'll set up our cosine inverse, and that is going to be what our x degrees is equal to. Cosine inverse of adjacent to hypotenuse, 31 to 36. All right, and in our calculator, we'll place that. 31 divide 36, and that is 30.556. So about 31 degrees. Okay, and I use that approximate little symbol, little squiggly equal sign. It's not quite 31 degrees, but that's a rounded estimate of that angle. All right, number 8. Okay, we're trying to find the measure of angle W. That's where we want to look, right there. That's right there. That's our theta degrees that we're looking for. All right, now again, we need two sides. So we already have this side that's 22. We only have two other sides to choose from. We're going to always choose the side that's also a side of the other triangle because we need help in solving it, and the other triangle is our help. Okay, so you want the one that's also a side of the other triangle. And here we have 25 degrees, and we have this side here that is the opposite side. Okay, and we want this side. So we're going to use the right triangle to help us find the information we're asked to find angle W on the left triangle. So we place that X on the combined side, or reflexive side, and we have opposite here, and this happens to be right across from the 90-degree angle, so it's the hypotenuse. So we're going to use the sine function on our right triangle to come up with that side X, hypotenuse of that triangle, so sine, because we have O and H. Sine 25 degrees, now we're not using inverse functions because it is a side we're looking for now. And when we're looking for sides, we use the regular function. So sine 25 is equal to opposite over hypotenuse, which is 15 opposite over x hypotenuse. Again, this is helping us find a side. We're looking for a side. So that gives us x is equal to 15 over sine 25. All right. And we're going to that was a switcher, right? We switched the denominator with that sine 25 sine function. So 15 divide sine 25 is 35.5. Okay, so that's this side here. And I'm going to have to erase a few things because it might not be the hypotenuse anymore. And now we know the measure. So we can erase x and put in 35.5. So we figured that out. And now we have two sides to relate to that angle 25, the angle Z that's the 25 degrees to that right triangle. And now we're going to look. We have the opposite already labeled. Everything's good with that. This is going to be across from the hypotenuse. So, the 90. So it is the hypotenuse. So we have O and H. And that's, of course, sine inverse, because we're looking for an angle. Remember, anytime we do an angle, we use the inverse function. Opposite over hypotenuse is sine, so sine inverse of 15 divided by that number, 35.5. Okay, again, I am going to pull over the handy-dandy stuff so you can actually check out on the calculator what to type in. So, now I forgot what it was. Was it sine inverse? Let's look real quick. Sine inverse of 15 over that number. Oh, and I might have just cleared it. Oh, no, it's right there. Okay. So sine inverse, second sine of 15 divide, and then again, I'm going to arrow up and grab that number, hit enter. Okay, so I'm dividing by it. Make sure you hit in the divide. All right, and it's 25. Wow, that's pretty odd. 25 must be a Pythagorean triple. So the answer is, let's see, what was it we're looking for? Angle W is 25 degrees. Okay, so there's that. How much time do I have? A little bit. I can set up at least the 9 and 10. I'm just going to help you set them up, but probably not solve them. You could do the remaining solving on your own. So a soccer ball is placed 10 feet from the goal, which is 8 feet high. So we have the goal net here. Okay, and it's 8 feet high. And then over here you have your soccer ball. I don't know. 10 feet away. Just looking for that. 10 feet. Okay, so this is going to be from the top of your goal here. That's going to make your right triangle, which is important to figure out where that triangle is. So 10 feet from the goal, 8 feet high, you kick the ball, and it hits the crossbar along the top of the goal. So it's going to hit this crossbar right here at the top of the goal. What angle does the ball make with the ground? Now this is important because eventually you could figure out what the top measure is and what that angle is, and then you can adjust the angle, try to kick it at a smaller angle, and therefore you know it's going to go right into the goal. And they actually do studies like that, believe it or not, to figure out how to kick the ball and get it right inside the goal. So you know that top bar is probably the most difficult to reach. So anyway, that's the setup. So you're looking at opposite and adjacent, aren't you? Opposite and adjacent. The hypotenuse across from the 90 is right there. It has nothing to do with this specific problem, other than it's part of the triangle that we're using. And that is tangent, and we're doing inverse because we're asked to find that angle, opposite over adjacent. And that's how you would set that one up. All right, setting up number 10, Jaden is flying a kite and lets off 275 feet of string. So there's the kite, 275 feet of string. All right, so this is Jaden here. That's his hand. And he's flying a kite. And he's wearing clothes. And anyway, that's probably not the best picture. But anyway, he has 275 feet of string. So where's the triangle? We need to find the triangle. The kite is 150 feet above the ground. And assuming the string is straight, what angle does the string make with the ground? Now, I am just going to use this triangle, which I know isn't the best because the string's coming from his hand, not the ground. But for this, we're going to use 275. We'll just use the measurements and we'll just approximate. If the kite is 150 feet above the ground, then this measurement here from the ground to the kite is 150 feet. Assuming the string is straight, what angle does the string make with the ground? Okay. So this string, we're just going to kind of continue it to the ground. What angle does that make? And we have the hypotenuse is the 275, that's the string. And this is opposite the angle that we're looking at. So O and H is sine, inverse. And then opposite is 150 and hypotenuse is 275. And that's what you place in your calculator to solve that one. All right, so you should be able to do those homework assignments. I set up the 9 and 10. I didn't finish them, and I guess I did finish 8, and I finished 7. So you'll have the rest of those to work on, and you should be good to go. So good luck with 18-4. Let's see.